Hi everyone, here we are going to study a very important concept known as perpendicular axis theorem. So the perpendicular axis theorem, it relates the moment of inertia of a given section or area. Suppose we are considering this particular area or this particular section. So the perpendicular axis theorem relates the moment of inertia of this particular section about an axis perpendicular to its plane and passing through centroid with two mutually perpendicular axes which are in the plane of this particular section and they are passing through same point, that is centroid of the section. Okay, so the perpendicular axis theorem relates the moment of inertia of this section about this axis with these two axes which are mutually perpendicular and they are in the plane of the section and they are passing through same point, that is centroid. So friends, according to perpendicular axis theorem, the moment of inertia of the section about this axis, that is Iz, will be equal to the sum of moment of inertia about two mutually perpendicular axes passing through the same point and they are in the plane of the section. So it means Iz equal to Ix plus Iy. So this is the final outcome of perpendicular axis theorem. So this is a straightforward understanding of perpendicular axis theorem. So we shall see some examples where we are going to use the perpendicular axis theorem. So we have understood here the moment of inertia of this section about this axis, that is Iz, equals the sum of moment of inertia about x-axis and y-axis. Okay, now let's see one example to understand the application of perpendicular axis theorem. So if I take a circular section like this, so this is a circular section. So the moment of inertia of the circular section about an axis perpendicular to its plane and passing through its centroid, we can say this C is the centroid of the section about this axis which is perpendicular to its plane and passing through centroid is called as polar moment of inertia, and this is given by pi r raised to 4 by 2. Okay, so r is the radius of circular section. Fine. So with the help of perpendicular axis theorem, we can also find moment of inertia of the circular section about its diameter. So similar to this, friends, let me draw one axis along the x-axis from here. So let me say this is the axis in the plane of the circular section and it is along the x direction. So we can say it is something like this, friends. We can just draw it like this. So this is again along the diameter, and we can also draw along y-axis like this, friends. So it is also in the plane of the circular section. So the moment of inertia about this axis along x-axis will be Ix, and the moment of inertia about this axis will be what? Iy, we can say. So friends, according to perpendicular axis theorem, I can say that the moment of inertia about this polar axis, that is Ic, will be equal to the moment of inertia about this axis, that is Ix, plus the moment of inertia about this axis, that is Iy. But friends, both Ix and Iy both are along the diameters. This is also diameter, friends, and this is also along the diameter. Both are along the diameter. Okay, it means Ix and Iy symmetrically they are equal. So since they are equal, I can simply write down that Ic can be written as Ix plus Ix because Ix equal to Iy, or it can also be written as Iy plus Iy because Ix and Iy are equal and they are along the diameter. Okay. So from here, a very simple outcome you will be getting. The Ic will be 2 times Ix, and for that matter it is same as 2 times Iy. So the simple idea is, you can say that therefore I can simply write down the moment of inertia along Ix will be same as the moment of inertia along y-axis will be 1 upon 2 times Ic. So Ic is basically pi r raised to 4 by 2. Therefore, I can write down this as what? Pi r raised to 4 by 4. So the final conclusion is very simple. So I can write down that the moment of inertia of circular section about diameter is nothing but pi times radius of the circular section divided by 4. So this way you can find out the moment of inertia of a circular section. This is a circular section, friends. Okay, about its diameter. Okay. So the moment of inertia of a circular section about its diameter is pi radius raised to 4 by 4.